Welcome back to Physical Science. We're talking about energy still. So, I want you to think about this. An object is falling. What happens to its gravitational potential energy and its kinetic energy? Well, as it falls, the height decreases. So GPE also decreases, because height is in the GPE equation. Yes, I know I did this yesterday. I'm refreshing your memory. Also, as it falls, it's accelerating, so the kinetic energy increases because velocity is increasing, and velocity is a part of the kinetic energy equation. In fact, every joule of GPE lost is gained as kinetic energy while an object is falling. On your note sheet, there's a space at the bottom for you to draw the flower pot in the apartment building. But I have thought about this, and I've come to the conclusion that I can't do that demo justice unless I'm there in front of you, getting feedback from you. So we're just gonna skip it. Alright? Alright. On this other note sheet that you got yesterday. Next topic. Energy can change forms. Of course, you know that because you're watching a change in form of energy. Electrical energy is being converted into light energy, and you're watching it with your eyes. Pardon me a minute. It's soda. Okay, let's move on. Figure out what kinds of energy changes occur in the following situations. These are the same situations that are on your notes. So here we go. The first one, an electric space heater is in use. What energy is being changed into what other form of energy? Well, it's electric space heater, so we're using electrical potential energy, and we're changing it into heat, thermal energy. Electrical PE converted to thermal energy. To the right of that, propane space heater is in use. Okay, so propane space heaters don't use electricity, not plugged in. They use propane and propane products. Thank you, Hank Hill. Propane stores chemical potential energy, so it's going to be chemical PE converted into thermal energy this time. Okay, next thing. A log burns. That's chemical potential energy being converted to thermal energy and light energy. You can see it. You can feel it. All the energy was stored up in the wood, in the molecule called cellulose, which is technically a form of sugar. So wood is technically a form of sugar. You cannot digest it, so don't go around eating trees. To the right of that, picture of a car. A car engine is running. What do cars run on? Gasoline. Gasoline is stored chemical potential energy. And what's the engine turn it into? Well, it gets warm, so heat, and it runs and moves forward. There's parts moving, so that's kinetic energy. So chemical potential energy into thermal energy and kinetic energy. An object falls. I started off today's little video with this. If an object is falling, you have potential energy, gravitational potential energy changing into kinetic energy. Okie dokie. Are you ready? There's this thing called mechanical energy. It's on your notes above the word projectiles. And there's a definition. The sum of kinetic energy and gravitational potential energy is called mechanical energy. While an object is moving, while it is moving because of gravity, not anything else, but while it's moving because of gravity, mechanical energy does not change. It's not just falling we're talking about, we're also talking about swinging as a pendulum. It's only moving because of gravity. Let's get to that, shall we? Let's apply mechanical energy to two situations that are drawn in there for you. So when an object falls, we know GPE is converted to KE and ME does not change until it hits the ground and knock is changed into something else. How about when an object is thrown in the air? How does mechanical energy work there? Well, and there's a picture of an object thrown in the air. You have a picture of a cannonball going up, top of the arc, and then going back down. So we're going to use that. As projectile rises, it gets higher, increasing GPE. So on your picture, you have a cannonball going up. There's an arrow underneath that says increasing PE. On top of that is decreasing kinetic energy. Hold on. Sorry about that. Somebody printed something and the printer's behind me. So, what was I? As projectile is rising, gravitational potential energy is increasing because it's getting higher and higher in the air. Also, if you've ever thrown like a paper ball or a football or anything up in the air, you know it slows down and stops for an instant and then starts falling again. So the speed is decreasing. So as the projectile is rising, gravity slows us down, so the kinetic energy decreases. Every joule of kinetic energy lost is gained as gravitational potential energy. It reaches some high point where gravitational potential energy is maxed out. Kinetic energy is at 0. It actually stops rising or falling. All right. Then it starts falling again. At the top of that path, it stops one instant, so KE is 0. This also has maximum height, so GPE is at a max. I just said that. In fact, you might want to add that to the picture at the very tip top of that curve. So, pause the video, write this part here down, summarize it, and then come back. Okay, you're back. On the way down, the GPE decreases because of the decreasing height, and the KE increases because of increasing velocity, just like if you drop something off a building. Okay, and that's in the picture of the cannonball going down, increasing KE, decreasing GPE. You get it? You got it? Good. The whole time it's rising and falling, the mechanical energy stays the same. The GPE plus the KE always adds up to the same number. Okay? So one goes down, the other goes up, but they both always add up to the same number. For a pendulum, swinging weights, same thing. As the pendulum swings, kinetic energy is converted to GPE and back again. Mechanical energy does not change. You have a picture of a pendulum motion. In fact, why don't I just take this and throw it over here? And throw it over here. There it goes. You can see it now. It says all these positions where it says PEKE, 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 etc., etc. Make it bigger. Ooh, wow, it's way bigger. There we go. You can see it now. All right, so at position 1, that's as high off the ground as it gets. You've been a pendulum before, all right? You've swung in a swing before. Please tell me your child was not that deprived, that you were in a swing at least once in your life. Thank you. So if you remember the fun, maybe some of you are having that fun now because we're all isolated, so I can do a swing outside. Whatever. At the top of your swing, as far back as you're going, before you start going back forward again, you're as high up above the ground as you're going to get, so your PE is maxed out. Your kinetic energy is 0 right there. So write max right there and write 0 right there. Alright, on the way down, and y'all see me look onto the side because the screen where I'm recording is over there. So pardon me looking over to the side, not at you while I'm doing this. You can forgive me, or not. At position 2, potential energy is decreasing because it's getting lower and lower. Kinetic energy is increasing because it's starting to pick up some speed on the way down. So PE decreasing, KE increasing. Write that down. At position 3, potential energy is at a minimum. I'm not going to say 0 because you have not hit the ground. If you're swinging and you hit the ground, you need to adjust that swing. Okay, it's going to hurt a lot. But it is at a minimum because you're as low down as you're going to get during that swinging motion. Kinetic energy is at a maximum in position 3 because you're going as fast as you're going to go. Then you start rising again. On the way up, potential energy increases because you're getting higher up in the air. Kinetic energy decreases because you're slowing down. And then position 5 is going to match position 1. PE maxed, KE is actually 0. You do stop for 1 instant while you're swinging, then go back the other way. Whew. Okay, let me move that out the way. And come back over here. Oh, look. My animation of a pendulum swinging. Yay. Everything I told you, write down. If you didn't get it all, or you didn't care, you have no excuses now. Pause. Copy. See, that way, right? Pause. Copy that down. And then come back. Okay. Law of conservation of energy. Big, huge spot at the bottom right-hand corner. You can write this down. Energy can neither be created nor destroyed. We can only transform it. Write that down like my last grade. Get it? All right, good. Basically, you cannot just have energy poof out of existence. You cannot have energy just poof into existence from nowhere. All the energy that's in the universe is already here, in the universe. The total energy in the universe cannot change, cannot increase or decrease. It can spread out, but it cannot increase or decrease. It can go from place to place, but it cannot increase or decrease. Okay. That's fine. Let's see if you're paying attention. If your mechanical energy while swinging on a swing cannot be destroyed, why do you stop swinging if you're not pushed? I want to make that the question. So when you see this, you've already seen the question. I'm going to make that the question. You have to answer that question to show me that you did this work. All right, that's all for today. See you again tomorrow. Bye-bye.